All right, guys. So we're going to talk about 18.2, the Earth and the cycles. So a calendar is just a mean of keeping tracks of all the days in a year. Many civilizations have come up with different calendars based on different things: sun, moon, stars. So even back in Egypt, the ancient Egyptian time, goodness, it's a tongue twister for me. They divided it into hours. They used I'm going to butcher this, obelisk, I think it's pronounced. Were built to separate days into parts, and so it's usually indicated by a large pole of some kind with a circular object on the bottom, breaking it down into different parts. Some clocks were even water clocks, which just means the slow drip of the water counted out the amount of hours left in the day. Today we divide each rotation of the Earth into 24 equal hours. They're not perfectly equal, like we've talked about, but for our purposes, we just kind of divide them up like this. Each hour is divided into 60 minutes, and each minute is divided into 60 seconds. So the lunar cycle is just the gradual change in appearance of the moon. That is the lunar cycle. The lunar cycle occurs because of the relationship between the Earth and the moon and the sun. Although the lunar cycle is continuous process, there are 8 recognized phases. So you have a new moon or no moon, waxing crescent, which means waxing means getting larger, quarter moon, waxing gibbous, full moon, waning gibbous, waning means smaller, last quarter, waning crescent, and then new moon again. So the orbit of the moon is tilted about 5 degrees from Earth's orbit. So you got us on our axis, which creates seasons, which we'll talk about. And then you have the moon, which is on an angle of about 5 degrees. The lunar cycle is caused by the angle of the moon makes with Earth and the sun and the Earth's orbit. So the reason we get these cycles is because of, you got everything rotating. You got the Earth rotating, us rotating around the sun, the moon rotating around us. So the moon is not in Earth's shadow except during an eclipse. So it's always kind of out there. We can always kind of see it unless it is eclipsed by the sun. The sun-facing side of the moon is lit by the sun almost all the time. So you have the sun-facing side and the dark side of the moon. The light side of the moon faces the lighted side of the moon faces away from the Earth. However, the moon appears to Earth dwellers as a different position as it orbits. So once again, all these rotations give us this cycles and these phases of the moon. A lunar eclipse occurs when the Earth's shadow falls on the moon. Because the tilt of the orbits and everything that's going on, our shadow doesn't block the sun from still hitting light. So we do have a lunar eclipse. And then we also, so here's an example, kind of a larger picture. So the Earth kind of here is blocking the moon. And it's only for a while. You'll see it if you ever get one. You'll see the moon will be whichever phase of it is. And it'll go slowly dark and then it'll go slowly light again. And that's just because the Earth is moving and the sun is moving and the moon is moving around the Earth. A solar eclipse happens when the moon shadow falls in front of the Earth. So here we have the moon in between the Earth and the sun, and we get a eclipse, the total eclipse. So you can have a total or partial. It depends on kind of where you are on Earth and where the tilt of the axis is and the seasons and all those kind of things. So it just kind of depends on the locale and where you are. All right, the seasons. The seasons are caused by a 23-degree tilt of the Earth's axis. You've probably kind of heard that if we were tilted, a whole lot more one way or the other, one way we would burn up, the other way we would freeze to death. So during the summer, the northern hemisphere gets most of the light and the southern hemisphere gets less of the light. So in this case, we would have, in this instance, this picture right here, we actually have winter for us, which would be the northern hemisphere, and summer for the southern hemisphere. So we have our equinoxes, which are first day of summer, first day of autumn, first day of winter, and first day of spring. The path of the sun across the sky in the northern hemisphere during the year shows the position on the first day of each. So we can see in the summer, the first day of summer, it's very high. First day of autumn and or spring, it is medium. And then the first day of winter, it is fairly low. This is why during the winter months, it gets dark at 5:30 sometimes. That's all we got for 18.2. Make sure to take your notes and send them in.